all for the great questions as well. Next, I would like to bring on the stage Dharmin, heading Uber AI with a special focus on, first of all, the Michelangelo machine learning platform at Uber and the safety and incident response operations of Uber. And Dharmin is an ex-colleague and again a good friend of mine. My memory of the time of Dharmin and me working together is the following. Like, together, in my mind now, looking back, together we built the first and second generations of predictive maintenance systems for industrial machinery. Right? So I've been through a few of these different variants of predictive maintenance, and Dharmin was a close, fighting buddy, going along during the journey for generation 1 and 2. So Dharmin, please come on stage.
Can you switch mic?
Oh, this mic?
Yes.
Just check. Hey everyone, very excited to be here. I'm Dharmin Parikh and I'm the product lead for Uber AI. As Vin said, I go back to industrial settings, industrial world, and moving into consumer world. So we'll spend some time today really talking about human-centric AI. But before I sort of dive into it, quick show of hands, how many of you are data scientists, applied scientists, machine learning engineers? All right, almost everybody just popped up. How many of you are business leaders? All right, there's some repeats as well. And how many of you are ethicists? All right, we generally don't find those. There are a few, but who really actually play a big role in human-centric AI. So we're going to go from level 3 to level 5 systems to come back to level 1 and really talk about how taking a very, very simple example of a real-time ID check for Uber, we'll discuss several human considerations that we need to take into account in order to deliver and launch an application for the real world. Okay, so just a little bit of background. Most of you probably have used Uber or Lyft or any of the apps. In the gig economy, AI is really powering magical experiences for our users. It learns when you're going to take a new ride or what your destination would be. From personalizing your destinations to really personalizing the offerings for your products, to determining the ETAs to the routes, the apps make it very easy for you to request a ride and to go from a destination from one point to other point. If you are using the Eats app, it really learns when you're going to reorder, what you like at that point in time, and then what your preferences are and what you would really like to explore, whether it's a new store, a new restaurant, or a new food item. All of these, if you think about it, they are really touching human beings. So at the foundation, all of these experiences need to be centered in human-centric AI. So the big question is like, what is human-centric AI? It's very simple. There are 3 key principles in my mind. First, it needs to serve the needs of various stakeholders. It includes, in Uber's case, riders, eaters, couriers, and drivers. They just need the AI to be useful and usable. All of the builders that are over here, other than just making your model very accurate, you need the AI in the field to be reliable and controllable when things go wrong. There are partners internally at Uber that I've worked with, policy, legal, marketing, comms. There are external stakeholders, such as regulators and advocacy groups. They all need your AI to be explainable, to be fair, and to be safe. So that's point number one. It needs to serve the needs of various stakeholders. It's not just about building the best possible model you can build and just deploying it. The second key point is, just like any software system, there are going to be edge cases, and you will need to understand those edge cases, which you can only do by human knowledge, and encode those edge cases in form of rules, whether it's pre-processing, post-processing rules, to augment the performance of your underlying models. The third most important thing that I've learned is that at the end of the day, it's about controlling AI. The humans need to be able to control AI when needed, especially when the stakes are high. In hospitals, I'm sure there has to be exceptions and scenarios where you need to go and be able to control the AI. So these are three very simple principles that will take a simple example of a real-time ID check. Real-time ID check is a tool used by Uber whenever a driver is trying to go online to give rides. A little bit about safety at Uber. I spent 3 years at Safety. It's a very, very mission-driven organization where I spent time. Almost everything at Uber that we build is really grounded in safety. It's very critical because people are not meeting just online. We are making people connect in the real world in real time. So a very foundational thing that we do before a driver comes on board Uber is multi-step safety screen. This is background check and other safety screens. We want to make sure that our riders feel very comfortable and they trust Uber when they take a ride with us. Now the question is, let's say we do a background check, everything looks fine. We don't know who is actually signing into the app. So we want to make sure that it's the same person who onboarded our platform signs into the app. As a result, we have introduced real-time ID check. As you can imagine, what it does is every time the driver opens the app, we basically ask them for a selfie, and they take a selfie, and we just use the selfie and the photo that we have on the file, and then verify it with a face verification API. Now, we're using a third-party API, but there's a lot that goes behind the scenes. Now, the happy part is the selfie matches, and the user basically, or the driver, can go online. So we can just close the presentation here. The problem is there are many stakeholders, and this is a classic 2x2 that you would look at and say, happy path is great, but what if there was an imposter who was allowed to go online? What if there was a driver who cannot drive just because your face verification API said this photo doesn't match? Either you have a poor driver experience who cannot make a living, or you have a poor rider experience who probably loses trust in Uber, or worst, it could lead to a very, very bad experience in very, very rare cases. So it's very critical to make sure that we deliver the best-in-class experience for our users. So the first step that we took was, we tried to test this system, and we realized in the real world, there's a lot of things that can go wrong. There are different phones with different sizes, different capabilities. Some people take photos in low light conditions. Some people take selfies while driving. Some are wearing glasses. Some have changed their appearances over time. There's glare, there is blur. So there are lots of issues, and we built a set of on-device models and offline, and in the back-end server models to be able to detect such situations before we even decide whether this selfie is good enough for us to compare with the profile photo that we have on file. So that's the first sort of connection to experience. A model that is just trained based on samples of data doesn't really know any of these things because they're pretty much filtered out. You can only learn when you start testing these things in the field, and that's where you start collecting knowledge and you embed knowledge in form of rules or in form of other models, and you start building your systems out. Still, the question remains, what would we do if the face verification API says, hey, the selfie doesn't match the profile photo? Should we block the user or should we not block the user? How many of you say we should block the user? Oh, we have a smart audience. Yeah, there are several considerations. There's a rider safety impact that I talked about. There's a driver earnings impact, because a person really would not be able to make a living if you block them. There's a business impact. We reduce supply, can't make money. There's a fairness impact. If the API actually systemically affects a particular cohort of drivers, then that could have a fairness implication and potentially regulatory implication as well. So this is where what we do is, in real time, when the face verification API says, hey, the selfie does not match the account profile, we send the selfie to real-time humans in the loop. There are 3 agents who review each mismatched selfie with the profile photo independently and decide whether it's a match or not a match. Once that happens, if the consensus says that, hey, this selfie is not matching, that's the time when we decide to block the driver. So this allows us to make sure that we can be very precise. The question is, we use humans to really make the AI more accurate, if you will. The question is, we are humans after all. So how do we make sure that humans can actually meet the bar that we need? So we actually use a Glasgow face matching test. This is developed by cognitive psychologists to make sure we set a bar for anybody who becomes a human agent. And we make sure that almost on a weekly basis, we have audits of how these agents are performing. So that allows us to ensure that there is accuracy built into the system that is deployed in the field. The next question is, despite all of this, humans can still make a mistake. So how do we make sure that we are allowing our drivers to really have some sort of recourse if they firmly believe that they are not being treated fairly? And that's where we built experience to make sure that they can appeal a particular block that happens on their account. And then we have expert panel that reviews the entire history of user and their selfies to understand if a person has gone through a facial change or if there is really genuinely a person who is an imposter. So now this is a very simple use case. The point I'm using this simple use case is that as we start talking about the more advanced use cases, the complexities are just going to increase. And that's where really leveraging humans in the loop or leveraging human experience is going to become even more critical. The other elephant in the room is, aren't the facial verification systems biased? There's multiple academic researchers that have done some research that have also shown that from a classification perspective, gender classification perspective, commercial solutions do have bias built in. And it really depends upon what the training data was used. You all are experts here. You know how this works. The challenge here is discrimination does occur on a color-based basis or for transgender people or people who have gone through some facial surgeries, right? And in those situations, the question is, should we use facial verification system? Now, this is gender classification-based discrimination analysis to make sure that we are not treating any particular cohort in a biased way. We have a panelist of ethicists. Our policy team has data scientists who actually do analysis, and what we did was we looked at outcomes that really matter to our earners. Is there, like, are there dark-skinned people or transgender people who are actually being blocked in a systemic way? And does it lead to either higher delays or their inability to earn on our platform? So that's the level of fairness testing we did, along with working with various fairness groups to make sure that we are doing the right thing. And we do this on a periodic basis to make sure there is fairness built in the system. The point of this slide is that it's not just about making the AI as accurate as possible. It's about considering various other stakeholders in your ecosystem that you're delivering your solutions to and to make sure that you have the right affordances built for them. So with this, I'll just leave you with three key points. We looked at how a very simple application like real-time ID check, when we build it, we considered for various stakeholders into the system. We served the needs of those stakeholders. Second, we encoded human knowledge either through pre-processing or through post-processing or through human in the loops. And third, we have processes and control put in place to make sure that the AI system is controlled by humans. That's it.
Thank you. Very good presentation. For cases of discrimination, we're dealing in a domain that doesn't have prior knowledge. You're pulling it from the cohorts, your internal working groups and stuff. How do you know whether the rules they come up with are right and are working? How do you measure that?
So it's a good question. First, I think we have to start with the users, what really matters to them, right? If you look at the drivers, what matters to them is, now I'm giving a very general answer here, but what matters to them is earnings, right? What we know is there are different demographics of drivers that exist, and we're fortunate to have a lot of data. We cannot store ethnicity or any of the data, but we have to, there are industry standard practices to really figure out, to really leverage it for the purpose of fairness testing, how we look at various cohorts, right? So that's how we look at various cohorts. The question is, what metric do you use? For drivers, it's more of earnings. For riders, it's more of wait times, right? Or not being able to get a ride, right? So any decision you make, is it affecting the key metrics for a driver or rider experience? And if there is a cohort or a segment of population, whichever way you want to slice it, if that is getting adversely affected, then you have to go back to the drawing board and figure out, okay, is my training data not right? Do I need to correct for those biases into my outputs and then make decisions?
Hello. Hello. Thank you for your presentation. Actually, some of my friends still use old smartphone, and the camera quality is not that good. Would the voice recognitions be an option here?
It's a good question. We considered various other sort of biometric methods. We finally decided on facial recognition, just because if you have voice recognition, there's a lot of other aspects that also come into play, like noise, and you have to really work through all of those things. Also, voice also changes over time, right? So same set of challenges do occur there, but from a coverage perspective, I think most of the phones that the drivers use at least allow for a decent enough camera for us to be able to capture the selfies.
Regarding, I think this talk, going back to the keynote this morning, focused on encoding human knowledge. And this may be technical since you are our product, but I would like to know how these rules are encoded and what's the process or method for updating them or making them adaptive.
Yeah. So first step, I think, is anytime we do build features, we are encoding rules. That's where it starts, right? So we're continuously looking for features, building features that allow us to improve the accuracy of our models. I think that's like one way of looking at it. Second way is we are continuously monitoring how the model or the application performs and where it is not performing well. It could be by a particular state, by a particular geo-hash code. It could be by a particular cohort of population or by certain phones. and we need to be able to figure out what are the segments where the application is not performing well, and then we might have exceptions that we put in. So we generally we have a layer of rules on top of any predictions that we build, and then basically that's the layer. Sort of think of it as a rules engine that allows us to configure for various types of scenarios what the decision is going to be. So model is like just a one sort of piece that provides, and you can have multiple models providing their own sort of scores, but then to convert that into decision, you need a.
Quick follow-up on that. Are these rules programmatic in the code, or are they at a more accessible?
They need to be configurable. Programmatic in code works if you have like a simple problem to be solved. If I look at various places where Uber uses AI, basically we want to be able to build a platform that makes it very easy to be able to configure rules.
Yeah, I just want to follow up on that. I think by the time process or anything turn into rules, it's become a process. So who own that rules, and when you want to make change to the rules, especially those that really critical for safety and brand for Uber and things like that, how did you carry out that change?
Yeah, I don't think there's going to be one answer that'll satisfy you, but there is always going to be ownership of the product. So the product and engineering team will own the maintenance of the rules, but the new rules that are created, it could be based on geo, right? There might be a regulatory need to be able to configure a particular rule. Then you might be able to have an operations team inside that particular geo to be able to configure that rule as well, right? So it is combination of like there are set of standard sort of rules that apply across the board that would be controlled by product. But then there would be operations teams that basically would configure rules depending upon who owns that particular metric for that given geo.
Just in general, what are the largest areas of growth for AI at Uber aside from person validation? I mean, obviously you have ride pickups, you can try to get
Sure.
people at pricing. Like, what are some of the three biggest areas?
There are several areas that I can talk a little bit about. One, we want our earners to be able to get on the platform as soon as possible so that they can start earning. We're leveraging a number of technologies, computer vision, natural language processing based technologies to be able to address problems. There are problems such as personalization that are very critical. So we are definitely addressing those problems across the board using all sorts of technologies that are available to us. There are issues related to matching, issues related to pricing. Definitely that's where AI is used. I was in safety and we use machine learning in the realm of safety as well.
Hi, thanks for your sharing. So I have a question about, so what I see you are using face verification API from a third-party provider. So how can you protect the user data? And is the data will be saved in the provider platform in the server?
No. So definitely that's the most important area. And the reason I did not add that to the slide deck was anything you build needs to be privacy aware first and privacy centric first. We need to make sure that the data is not saved at the third party provider. But even internally, the way you store the data, the amount of duration you store the data, you need to have policies put in place and then systems built that make sure that you deliver the data retention policies or data adherence policies. Different geos, different regions have different requirements. It could be like you have GDPR in Europe, and then you have different requirements in different geos that you need to be adhered to. So there are processes and then there are systems that every other system has to integrate with to make sure that your product is privacy aware.
For sure, protect the user data, but how can you make sure like third-party providers they are not, going to use the data?
So they need to be. So they need to be compliant, right? So that's why selection of third-party provider cannot be just any third-party provider, right? So there's a big due diligence process that goes in there, and that drives the selection of third-party provider, absolutely. Sure.
Thank you very much, Dharmin. Everyone, please give Dharmin a round of applause.